So we will first start switchgear. Now, before we get into the switchgear testing and commissioning, we should understand what are the switchgear and what are the varieties of switchgear and what are the intricacies inside it, so that we can feel this kind of testing is necessary, that kind of testing is necessary, this specification is important, that is not important. This kind of discriminatory mind we can apply. Human has got a why human is superior than the other creature, because we have got a discriminatory mind. We can take a decision, we can analyze it, and God has given us a very intelligent brain by which we can do that. So whenever we'll be starting the session, my preamble is we must understand the main subject, because the testing, only when we understand the main subject fully, then only the question of testing, question of commissioning, question of taking precautions, safety, operational hazards, etc. comes into the picture. Now, for first slide, is it visible?
Visible, sir.
What is a switch? Switch is a device that closes or breaks an electrical network or equipment to and from an electrical system. That's a switch. Then why we are bothered about switch gear? Because gear is a device that couples or decouples a mechanical load. Why mechanical load? Because whenever we're talking in terms of the high voltage or extra high voltage circuits, where there will be phenomenal amount of load and the phenomenal amount of short circuit current that can happen due to a fault, because you can never know when the fault will occur. So today, or even fault can occur at any point of time. And when a fault occurs, the fault could be how many types of fault? There could be a different kind of fault. One could be short circuit fault. One could be face-to-face short circuit fault. One could be face-to-ground fault. One could be two-phase short circuit fault. Two-phase short circuit to ground fault. So each variety of faults has got a phenomenal amount of current to handle. And whenever a breaker, what is the purpose of the breaker? The purpose of the breaker is switch on and off. Switch on and off, not the load, but also the faulted condition. So, who pumps the switch gear to isolate during a fault condition? Who pumps?
Relay sense, sir.
Correct. So, relay is the intelligent device which is placed in the switch gear in the control panel. And who feeds the relay? Who feeds the relay? Or where from the relay gets the signal?
CT secondary के साथ relay होता है, तो
correct. CT and VT. CT and VT. And apart from, there are some kind of relays which also senses temperature. So you have a RTD or PT100 thermal sensors. You have some other kind of like pressure. Say, for example, you want to operate the pressure release valve of a transformer. That's absolutely a mechanical thing that is there to prevent a transformer from explosion, from the fire hazards. So it's operated on a pressure switch. So that pressure switch ultimately gives a trigger to some auxiliary relay or master tripping relay, which gives the final signal to the breaker through a 220 volt DC or 110 volt DC command. And in the switch gear, there is a coil which is known as trip coil, which gets energized. And soon it energized, it triggers, it hits the tripping bar, and the mechanism trips. And once the mechanism operates, the switch gear opens. Now, when it opens a huge amount of load, which could be in terms of kiloampere, and at that voltage. So therefore, it cannot be a simple switch. Let's take an example. I think you are having geysers in your houses or AC in your houses. Can you put a normal piano switch for a geyser or AC? You can, but it will work for one or 2 days, because that switch is not supposed to handle that amount of current. Because when the geyser is on, it is taking a huge amount of current. When geyser gets switched on from the cold water, it takes a very high current. Then current subsides. Similarly, for the air conditioners also, it has got a motor. It takes a very high current. So the piano switch cannot handle that current. And if we want to break it, because these are inductive or resistive, whatever be the load, so that load current breaking becomes quite difficult, because the piano switch does not have any mechanism to handle the arc. because whenever there will be a breaking of the switch gear, some arc will be involved. Do you know why the arc will be involved?
Sir, any arc will be involved because any short circuit or occurred and any fault current which is flow to ground because मतलब एक पोटेंशियल डिफरेंस काज करता है। आर्क सब ऑल टाइम जीरो पोटेंशियल में रहता है, उसके आर्क, इसीलिए आर्क के रेस्पेक्ट में हम लोग आर्क को डिफरेंस मानते हैं। उसके बीच में एक पोटेंशियल काज करता है, पोटेंशियल डिफरेंस काम करता है। जब कोई शॉर्ट सर्किट और फॉल्ट ऑकर होता है तो हमारा टारगेट रहता है उसको आर्क में बाईपास कराना, इसीलिए आर्किंग किया जाता है सर।
No. I'm not talking of arc. EARTH now. Arc. ARC. Arcing. I'm talking of arcing. What is arcing?
आर्किंग मतलब होता है जब कोई दोनों इलेक्ट्रोड सेपरेट होता है तो उसके बीच में जो एआर मॉलिक्यूल्स होता है तो वो आयोनाइज हो जाता है। मतलब ड्यू टू क्लोज, मतलब दोनों इलेक्ट्रोड का बीच में जितना डिस्टेंस कम होगा उसके बीच का जो एयर मॉलिक्यूल्स है वो ज्यादा आयोनाइज होगा। तो आयोनाइज होने के वजह से एक वहां का जो एक वहां का फायर शो करते हैं, उसको आर्किंग बोला जाता है।
Indranil, you tried your best to explain, but what is the but you could not hit the answer. What is the reason why an arc develops? So, for example, when you switch on off a piano switch number of times for which is controlling a 1 kilowatt geyser, you will see the flash comes out. That's an arc. But why it comes out? Because it is within a switch box.
When we suddenly switch on an inductive load, it doesn't allow the sudden change in current.
Correct, Nasrullah, continue.
So,
सर उन्होंने सही कहा सर, इंडक्टर जो होता है वो एसी करंट एलडीआईडीटी जो फेनोमेना होता है वो क्या करता है, एसी करंट को जो चेंज होता है उसको अपोज करता है ड्यू टू एक्सएल इज इक्वल्स टू 25 एफएल, और डीसी करंट को बाईपास कर देता है।
अच्छा, ये मुझे बताइए जे आपका जब तक तो गीजर में तो रेजिस्टेंस ही रहता है, गीजर में जो एलिमेंट है वो तो रेजिस्टिव एलिमेंट है, उसमें तो कोई इंडक्टर नहीं है, तब तक ऐसा क्यों होता है? गीजर में जब तक ऑन ऑफ करेंगे तब तक अब देखोगे तो आर्क भी हो जाता है, कि क्यों ऐसा होता है?
सर उसका हीटिंग इफेक्ट की वजह से I2RT।
Any other views from any other views from any other participant? Hello. আমি ক্লাসের মধ্যে আছি মিস্টার সোমনাথ, আপনি একটু আমাকে বিকাল 5টার পরে ফোন করলে ভালো হয়। কি আপনি কি জানতে চাইছেন বলুন তাড়াতাড়ি। হ্যাঁ 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 ওটা আমরা করি। ঠিক আছে, আপনি 5টার পরে ফোন করুন, আমি আপনাকে বলে দেবো। আচ্ছা, তাহলে লাঞ্চ ব্রেকে কথা মানে টি ব্রেকে কথা বলবো 11:30 বা 11:15 নাগাদ। হ্যাঁ, হুম, हेलो या
जो आप बोल रहे हैं उसमें एल सीरीज और जी सीरीज टाइप्स ऑफ एमसीबी यूज किया जाता है, आइदर एल सीरीज और आइदर जी सीरीज। तो उसमें जो प्रोटेक्शन के लिए जो यूज होता है वो तो एक कॉन्टैक्ट मतलब एमसीबी यूज होता है, एल सीरीज और आइदर जी सीरीज टाइप्स ऑफ एमसीबी।
No, my question is very simple. Why arcing happens? Whenever you attempt to switch on and off a circuit, why arcing happens? That's my very simple question. And let us answer me point blank.
Sir, insulation.
Yeah. Transient.
Yes sir, मतलब एक आप जिस इंस्टेंट पर स्विच ऑन हो रहा है तो जब स्विच क्लोज होता है तो वो मोमेंटरी फेनोमेना के लिए उसमें एक हाई राइज करंट फ्लो होता है.
Now, why you are talking of transient? What is how transient comes into the picture? Just सोच के थोड़ा बताइए.
Sir, due to frequent tripping, insulation of the wire get damaged.
Who are you, Grover?
And yes, sir.
Okay.
Yes, sir.
Tell me.
Sir, due to
Tell me.
frequent tripping,
Yeah.
sir, due to frequent tripping, the insulation of the wire get damaged, and that's why arcing takes place.
No. Anybody? Any other answers? From anybody? Achha, all 10 participants joined, or there are a few more to join? All 10 participants joined, or there are a few more to join? Hello?
Sir.
All of you joined? All of you joined?
All 10 are present, sir.
Achha. No. Actually, just take me account. Nasula, I heard your voice. Indranil is also there. Uday there. Sushant is there. Sumit Kumar is there. Sumit is there. Sumit.
Yes, sir.
Okay. See, your voice is not coming. Grover is there. Gaurav is there. Gaurav is there. Gaurav is not there. Vipin is there. Vipin is there.
Sir, VPN is available, but due to some network congestion, is called on hold, sir.
Oh, why not he is resolving this problem, because that becomes a
Sir. Actually, sir, we are working professional, and some urgent work came at site, and there some urgent call came. That's why there will be network connectivity issue, sir.
Oh, acha. So yeah.
Just we are adjusting our time. How we'll take the knowledge from you, sir.
So nice of you. So yeah, Ali.
Sir, Syed is not connected. I will call him, sir, and update.
Ashutosh.
I think he is also not available, sir.
So 3 persons are not there. One is Syed, one is Ashutosh.
Now Vipin is available, sir. Now Vipin is available.
Vipin, hello Vipin. Vipin, can you hear me?
Yes, sir.
Yeah.
Yes, sir.
I understand your professional hazard. Sometimes your boss calls, you have to go. But this is a very interesting discussion they are happening, and Indranil, Uday, Nasrullah, Samit, Sushant, Grover, they are trying to answer. Please do answer. Well, the question is, whenever we see a switch or a switch gear I'm coming. When we open a switch or we operate a switch, particularly during switching off, we find some arc is coming out from the corner of the switch. What is the arc, and why such arc happens during switching off? That's the question.
आर्क तो एक टाइप का फॉल्ट होता है सर.
हाँ, मान लो आपको फ्रिज चल रहा है, रेफ्रिजरेटर चल रहा है, वो पियानो स्विच को आप ऑफ करके रेफ्रिजरेटर को ऑफ बंद करने के लिए कोशिश करते हो. साथ में एक तो ना फ्लैश दिखा जाता है स्विच का पास में. एंकर का स्विच व प्रिज्म का स्विच जो लगाते हो उसका साइड में थोड़ा आर्क हो जाता है, और ज्यादा से ज्यादा करोगे तो उसको ब्लैक हो करके वो स्विच भी जल जाता है. तो मुझे मेरा सवाल यही है कि आर्क क्यों होता है?
सर ओवरलोड की वजह से होता है सर.
किसके लिए
सर? सिस्टम मतलब जो हमारा वोल्टेज है सर, थोड़ा बहुत ओवरलोड की वजह से होता है सर.
No. Nasrullah trying to answer.
सर, जब वो स्विच वगैरह जब मतलब क्या ऑन ऑफ जब जिस समय करते हैं सर, तो उस केस में क्या होती है, वो हाईली आयोनाइज हो जाती है, जिसकी वजह से एक लो रेजिस्टेंस
आयनाइजेशन क्यों होता है? What is the physics behind it? I wanted to know. The moment you understand the physics, you will also enjoy. You can also convince your other juniors or seniors.
हेलो,
बोलो इंद्रनील बोलो.
मोनो इलेक्ट्रोड का बीच का जो मॉलिक्यूल्स होता है वो उसका बीच का जो फील्ड एग्जिस्ट करता है, इलेक्ट्रिक फील्ड, उस इलेक्ट्रिक फील्ड के वजह से आयोनाइज होता है
ना। इलेक्ट्रिक फील्ड जब तक सेपरेशन होता है तब तक तो इलेक्ट्रिक फील्ड जनरेट होगा। सेपरेशन का होने का पहले ही कि जब तक स्विच दबाए हो तब तक तो सेपरेशन कंप्लीट नहीं हुआ, लेकिन तब तक आर्किंग शुरू हो जाता है। ये क्यों होता है?
फील्ड तो सर एग्जिस्ट करता है ना।
फील्ड तो जब तक फील्ड तो एग्जिस्ट करेगा जब तक आपको उसको सेपरेशन होगा, मेन कॉन्टैक्ट से करंट कैरिंग कॉन्टैक्ट सेपरेशन होगा, तब तक ही फील्ड उधर आएगा। और लो वोल्टेज में तो ये फील्ड काफी वीक है, तब तक भी क्यों होता है? ठीक है, देखो जो आपको बोलने चाहते हो, मैंने आई थिंक you thank you for first thank you all because you tried your best with your wisdom and knowledge. What happens, any load, as Nasrullah was trying to tell, any load, it might have some coil. Even if we talk about the geyser resistance, it is also in the form of a spiral coil. Whenever there is a spiral coil, there will be certain amount of inductance will be present there. There will be certain amount of capacitance will be present there. So whenever you switch on a load, in a AC, you might have seen some power factor. So the load consumes both active work by which it is delivering the work output, and it is also consuming certain reactive power depending on how much inductance and capacitance it does have. Now, the property of the inductance and the capacitance is to store certain amount of energy within themselves. So whenever, take an example, whenever you, before switching on a circuit, the total energy content of the circuit was 0, right or wrong?
Yes, sir.
Before switching a geyser, before switching a AC, before switching a refrigerator or lamp or fan, there was no energy inside it.
Yes, sir.
Now, as you switched on, it is consuming current, it is delivering the work, fan is working, light is glowing, refrigerator is cooling, etc., etc. And in the process, the inherent inductance and the capacitance connected with the load, they also store certain amount of energy. They are just like springs, they're storing certain amount of energy. Whenever you are going to switch it off again, as per the conservation of energy, it will again should go back to the zero energy condition. Now, the moment you try to switch off, the active work will be stopped. But what about the reactive energy? So the reactive energy that is stored into the system, that is going to liberate. And as you separate the fixed contact, the moving contact from the fixed contact, the energy content is going to dissipate to come back to the zero state. So that time the energy liberates in terms of arcing. Now, electric field is there to support the arcing. Electric field is there. Since the electric field is there, that's why the arcing continues. But arcing is basically a kind of ionic discharge, or the discharge of energy which was inherently stored in the reactive element of the particular load. So whenever any switch is going to be switched off, for a small load you don't notice. For a big load you will notice. For a DC load you will notice more, because DC does not have the natural zero. AC has got a natural zero, so to try to extinguish, if it cannot do in the first zero, it will try it in the second. If it fails in the second, it will try in third, so that the energy, when the energy content becomes zero, ultimately it will quench. Ultimately it will come to the extinction. But in case of a DC, you have to forcibly bring it to zero, because the DC does not have the natural zero. So that's why in a DC circuit breaker, the arcing is more predominant, more extensive, and it damages the contact more rapidly. So that sort of thing I'm going to say.